This program is presented by University of California Television. Like what you learn? Visit our website or follow us on Facebook and Twitter to keep up with the latest UCTV programs.
I'm Nathan Brostrom. I'm the Chief Financial Officer for the UC system, but a avid partner on the climate neutrality initiative. Now we are going to hear short presentations from UC graduate students who are doing innovative work to help us better understand climate impacts. It is critical to understand how global climate disruption will impact things like human health and critical infrastructure, because that understanding informs and inspires the development of innovative climate solutions. It is less expensive for society to invest in solutions now than to deal with the large economic costs that will result from climate change impacts. If recent events like Hurricane Katrina, Superstorm Sandy, California's wildfires, and the record-setting heat in India this weekend are indicative of the type of economic and social disruption that will result from climate change, these costs will number in the billions and billions of dollars. We can't come up with the right solutions if we don't understand the causes and impacts. The research that you heard about this morning informs the types of solutions that we'll be hearing about this afternoon. It also informs climate policy and can inspire political action. Because climate change is such a multifaceted problem, the solutions will be equally diverse. While we need new technologies, we also need new, improved coordination between existing technologies, creative ways to find hidden efficiencies, tools to spur cultural and behavioral change, novel policy approaches, and ways to facilitate collective action. It is now my pleasure to introduce the distinguished judges for the Climate Impact Student Pitches. Emilio Camacho advises Commissioner David Hochschild at the California Energy Commission on renewable energy, research and development of technology, energy efficiency, and power plant siting. Thank you, Emilio. Alexander Gershenson is co-founder and CEO of SupplyShift, a cloud-based supply chain management platform. Thanks for being here, Alex. Julie Hill serves on the board of directors of Anthem, owns the Hill Company, a real estate firm, and serves as a trustee of UC Irvine. Thank you, Julie. Amy Holm serves as director of programs and operations of the Climate Registry, a nonprofit governed by all U.S. states and Canadian provinces and territories. Thanks for being here, Amy. Danny Kennedy is Managing Director of the California Clean Energy Fund, a fund serving the ecosystem of entrepreneurs and investors working to transition to clean energy. Thanks, Danny. And finally, Mike Milkey serves as Senior Vice President of Environment and Energy for the Silicon Valley Leadership Group. Thanks to all of you for serving as judges. We are now ready to hear from our students. Each campus has selected one student to represent them in this competition. Each student will give a 3-minute presentation, and then I will invite them up to the podium while the judges record their scores. So our first student participant is Joseph Stewart from UC Santa Cruz. Welcome, Joseph.
Thank you. To understand the dire, potentially catastrophic impacts of climate change on biodiversity, let's go back in time 250 million years ago to the Great Dying, the third mass extinction event. Volcanoes in Siberia released carbon dioxide into the atmosphere, which destabilized the climate and acidified the oceans. Warming caused the oceans to release methane, which in turn caused more warming, and over 2/3 of plants and animals went extinct. That's a scary analogy to think about, but it's the same road we've started to head down today, this time because of our own fossil fuel pollution. In the modern context, we've already seen extinction of several whole plant and animal species tied to extreme weather events. And over the next century, we know that a large fraction of species will be vulnerable to climate-mediated extinction. So what can we do to save them? That's what my research aims to address. First, we need to better understand how climate change affects different types of species differently. For high elevation species, like the pika, which I research, Many high elevation species, the same adaptations that allow them to survive in cold mountaintop environments make them unable to tolerate higher temperatures. So when summer temperatures are too high, species like the pika can't gather food. They have to stay underground to avoid overheating. In a recent study, I document how rising summer temperatures have caused pikas to disappear from low elevation sites across California. And I use the same data set to forecast how the species will fare as temperatures continue to increase. For desert species, like the endangered lizard study, I use the California mega drought as a window into what's likely to befall the lizards all the more frequently in the future. Desert species are vulnerable because there isn't enough food for them to survive during droughts. Second, we need to assess which species are most vulnerable. I'm working with the California Department of Fish and Wildlife to assess which species are already living at the edge of their climatic tolerances, which species will be able to move on their own to track their suitable climate, and which species won't be able to keep up. But the current suite of tools commonly used for this type of assessment isn't fully up to the task. That's why I'm developing new models that incorporate species traits like their thermal physiology, diet, and dispersal ability. Finally, for those most vulnerable species, we need to find ways to save them. For some species, assisted migration, physically helping species move to track their suitable climate, may be an effective solution. For other species, like the endangered lizard study, I'm looking into whether habitat management, like native shrub restoration, could help make the species more resilient to changing climates. But there are 9 million species on Earth. A far more effective solution than trying to help each species individually is to rein in and reverse climate change. To that end, I hope that simply sharing these species stories with public radio, with National Geographic, with newspapers, will get people talking and help contribute to the political will to tackle the climate crisis. Thank you.
Thanks, Joseph. Well done.
Thank you.
In the assisted migration, is it like, take the pika, are you trying to migrate them to higher latitudes or higher elevation or both, depending on the species?
Yeah, well, so assisted migration is a great strategy for species like the San Bernardino golden mantle ground squirrel, which is a subspecies of golden mantle ground squirrels that's only found in the San Bernardino mountains. And it looks like the habitat for that species could disappear as soon as like the next 15 years ago. So the climate envelope could close on that. But there's potential areas in the Sierra Nevada, if we can find areas where it's not going to conflict with other species, where we could save the species into the future.
Thanks again.
Yeah, thank you.
Our next student is from our newest campus, UC Merced. Please welcome Brandi McEwen.
How sustainable is tuna compared to beef, pork, chicken, or farm fish? Food systems contribute 25% of global greenhouse gas emissions. That's more than transportation. Because changing diets may be more effective than technological mitigation options, it's important to bring greater public awareness of the link between dietary choices and climate change. The same type of analysis that is used to evaluate whether a Tesla or a Prius is a more sustainable choice is needed for food systems. While the climate impact of farm protein like beef is well understood, the climate impact of tuna is largely unknown. The problem is only a handful of studies have considered the climate impact of tuna fisheries. My research addresses this knowledge gap and brings new insights. Specifically, there are 3 sustainable practices at odds with climate change mitigation. First, the use of selective fishing gears. Second, a proposed ban of fishing on the high seas. And third, the desulfurization of marine fuels. My approach is the development of a life cycle assessment model. The model is unique because it's the first to include short-lived climate forcers and the refinery emissions for taking sulfur out of marine fuels. The model can assess the climate impact of tuna under different policy scenarios. Selective gears reduce bycatch. However, as shown in A, they use more fuel. The time series in B shows a sharp decline in the use of purse seines coincident with the moratorium on drift nets and an increase in the use of selective gears. The weighted average in C shows a steady increase in fuel use over time. Banning high seas fishing would allow the high seas to serve as an ecological bank. This would restrict fishing to exclusive economic zones where the sulfur and fuel is regulated. This is important because ships are high emitters of short-lived climate-forcing pollutants, including nitrogen oxides and aerosols such as black carbon and sulfate. Sulfate cools by reflecting solar radiation and changing cloud properties, whereas black carbon warms by absorbing solar radiation and changing and darkening surfaces with high albedo. So, as shown in D, taking the sulfur out of fuels diminishes the cooling effect of sulfate and increases the climate forcing of fishing fuels. Taking sulfur out of fuels also improves air quality, but there are added refinery emissions. The blue bars in E show a modest but significant increase in warming. Currently, tuna has a net cooling effect because over 60% of tuna is landed on the high seas. On the other hand, tuna landed within exclusive economic zones is an estimate of the climate forcing under proposed regulations. In this case, there's an equal and opposite amount of warming. Comparing this result to other farm protein, tuna has a larger climate impact across the board with the exception of beef. The definition of sustainable tuna changes when we include climate forcing in the criteria. These results can inform consumer advocacy groups and policymakers, an important step in communicating the climate impact of tuna to consumers. Thank you.
Thank you, Brandi. That was terrific. We have. Yeah. My wife and I have 6 kids, and they are, having been raised in Berkeley schools, they're hawkish about this, and they banned red meat. But now you've given me some ammunition to go back after them. So these are the proposed regulations would actually worsen the effect on climate change.
That's right, and that's why we really need to look at all of the policies that influence our dietary choices. And so these interdisciplinary approaches, looking at policy, looking at climate models, are important when we look at all of our food systems.
Does this also apply to other sport fishing and other?
Absolutely, because any type of fishing activities using marine fuels will have the similar climate effects when those short-lived climate-forcing pollutants are included. Yeah.
Perfect. Well, great research.
Thank you.
Our next student is from UC Santa Barbara. Please join me in welcoming Jessica Perkins.
Everything that we touch, see, feel, taste, and smell is made of chemicals. Chemicals are the building blocks to life as we know it, and many of the advancements to society and improvements to our everyday lives can be attributed to chemistry. That said, the chemical industry is responsible for about 7% of the world's CO2 emissions. When I was working in the chemical industry, we used a method called life cycle assessment to find ways to reduce these impacts. LCA is a method where you measure the impact of a product across its whole lifetime, including everything from raw material extraction through the end of life. Using this method, we could identify hotspots where making changes to the product design could have the largest impact reductions. So this is great, and the method is there, but the timing is really not ideal. Life cycle assessments are usually very time intensive, and often these studies aren't completed until a product is already on the market. Not only did this make it really difficult for us to keep pace with the rapid product development times for new chemicals, but I also had a really big uphill battle when I was trying to convince management to make changes after they had already invested in R&D, scale-up, production, and the marketing for that product. Change at this point in time is painful and it's costly. But right now, that's kind of the only option. You see, during the development of a chemical, very little is known about its life cycle impacts, especially about the release of that chemical during the use phase and at the end of life. So this creates a huge data gap, and at UCSB, we're trying to find a solution. As a researcher in the Chemical Life Cycle Collaborative, we're developing a rapid response online tool that will be able to generate the life cycle impacts for a given chemical with only the reaction kinetics or with the chemical structure. We're doing this by pulling together existing tools and data sets along with new research, including spatial and temporal fate and transport models, including quantitative structure-activity relationship models for chemicals, using also machine learning to build more predicted data, and big data platforms and cloud computing. This will provide R&D organizations with a method in which they can screen chemicals before they have to make decisions about investing in scale-up. Right now, I'm working with our industry partners to validate our methods and building case studies with companies like Dow Chemical, Unilever, Sherwin-Williams, and Ecolab, among others. Hopefully, by developing these case studies, we'll be able to ensure that this tool is actually useful in practice. I feel that if we can just close some of these data gaps, we'll be able to empower companies to be able to better measure and manage their impacts. Thank you.
Thank you, Jessica. That's fascinating research.
Thank you.
So the life cycle assessment, it evaluates the impact of climate change on the manufacturing process. Does it also look at finance?
There is life cycle cost accounting as well, and the impacts that I'm describing, there are hundreds of different impact categories that you can measure using life cycle assessment. So not only are these direct impacts on climate change, like global warming potential, ozone depletion, but also ecotoxicity, human health toxicity, a variety of different things. But there is also life cycle cost accounting that takes the cost with all of these stages into consideration.
So if the cost of carbon were high enough, that would be an additional impact to these companies as they make their decisions.
Absolutely.
That's great. Well, thanks again.
Thank you.
Our next speaker is Robert Arlen from UC Davis. Welcome, Robert.
Hi, thank you. At any given moment, half the planet is covered in clouds, yet most of the measurements we rely on to monitor changes in the environment come from satellite-based instruments. Now, unmanned airborne vehicles, or UAVs, can fly below the clouds, and they're a lot cheaper to operate than manned aircraft and cover a greater area than ground-based equipment. Fortunately, with the development and miniaturization of technology, unmanned aircraft and sensors have become more accessible. At UC Davis, I started the Unmanned Airborne Systems Project, and when we couldn't find a proper aircraft to meet our research needs, myself with a team of undergrads designed and built an autonomous model airplane of 3.5 meters in wingspan, almost 12 feet wide, in order to capture hyperspectral imagery. Now, the plane we developed outcompetes anything available on the market in terms of performance and cost. It's a fully electric airborne platform that flies for over 3 hours, carrying up to 6 pounds of any sort of equipment, and that's almost unheard of. We won funding from a citrus sustainability grant competition, and our current research focuses on detecting changes in soil moisture content and plant growth behavior in hopes to improve farm resource efficiency. However, the applications of our airborne platform soar well beyond that scope, and I intend to pursue with my PhD research in climate science that kind of work. Now, before I continue, allow me to quickly explain the significance of hyperspectral imagery with our current research as an example. When we capture a hyperspectral image, each pixel represents a spectrum of wavelengths and the associated intensities reflected from the objects observed. Essentially, that means when sunlight reflects off plants or soil, we can detect how much water is present, how quickly it dries up or seeps into the ground, and if the plants are healthy, diseased, or pest-ridden, based on the characteristic spectral profiles. The cutting-edge science and technology behind hyperspectral imagery is compelling, and the applications are almost endless. But unfortunately, this kind of data and analysis has barely reached its full potential. I intend to help make that happen. Now, you might wonder how this all relates to climate change. Well, let me share a few examples before I get off the stage. So, unmanned airborne systems equipped with hyperspectral imagers, gas analyzers, and other sensors can be used for land use management and ecosystem monitoring. They can directly measure trace gas emissions as well as carbon, monitor solar panels for efficiency and maintenance because dust collects on them, and they're useful for natural disaster response and assessment from wildfires to floods, hurricanes, you name it. They can even track seasonal changes in river morphology as channels shrink and swell and accumulate and deposit sediment over time. But the crazy thing is, these examples only scratch the surface of what UAVs can do. I have 5 seconds. The exponential amount of high-quality data that we can collect with unmanned airborne systems is an untapped resource just waiting to take off. And I'm looking forward to working on and witnessing the environmental capabilities they have to offer. I hope now you are too. Thanks. Thank you.
Thanks, Robert. As I had mentioned, I was just meeting with our insurance brokers and agents, and half of the firms we met with asked us about our drone policies. And I know we have a center of excellence at Merced that's looking at that, but do you have a protocol and methodology you use in terms of when they fly and where they fly?
Yes, indeed. And in fact, we need to apply for an FAA Certificate of Authorization, also known as a COA. And we haven't received enough feedback from them yet, so it's still in the process. However, I had to develop an entire operations manual and a budget and a number of other things that I wasn't expecting to do. But it's been an awesome experience, and I really see a huge future with unmanned drones.
It's terrific technology in many applications. Thank you, Robert.
Thank you.
All right, our next team is from UCLA, and they told me they both defended their dissertations last week. So please join me in welcoming Rose Sang and Marla Schwartz, newly minted PhDs.
Imagine a world where the amount of rainfall is reduced and the atmosphere is warmer, especially in some of the most populated parts of the planet. This could be the reality with unregulated black carbon emissions. Black carbon is the soot byproduct of incomplete combustion of biomass and biofuels, coal-fired power plants, and diesel engines. On the health front, 2 million premature deaths per year are attributed to black carbon. Black carbon is studied by scientists because of its unique properties, and that it's the single most absorptive of sunlight of all the aerosol species, and it's the second greatest driver of anthropogenic warming. In a clean environment without black carbon pollution, naturally occurring aerosols in the atmosphere reflect and transmit solar radiation. However, in a polluted environment, black carbon in the atmosphere absorbs solar radiation, which warms the atmosphere aloft and reduces the amount of solar radiation that reaches the surface, slightly cooling the surface. Additionally, black carbon can interfere with cloud formation and also precipitation generation.
Thus far, the effects of black carbon, specifically for the Western United States, has not been studied. So we don't know whether the changes to temperature or the changes to cloud is more important for our drought-stricken region. So at UCLA, we've improved on a state-of-the-art weather forecast model to specifically study the effects of black carbon. And in doing so, we found that the changes to temperature far exceeds any changes to cloud. And this temperature change is interesting because of the warming aloft and the cooling below. And this cooling below, coupled with this warming aloft, actually works to stabilize our atmosphere. The stability is not a good thing. The stability works to reduce precipitation. Additionally, the stability reduces the amount of vertical circulation that allows our atmosphere to ventilate, essentially working to trap in black carbon emissions that's emitted at the surface, exacerbating health effects and precipitation impacts.
Our research of black carbon effects in the Western United States serve as a testbed for understanding impacts of black carbon at the global scale. This research indicates that effects of black carbon are likely to be greatest in regions that heavily rely on inefficient cook stoves or in regions of the world that currently have no black carbon emissions regulations. This research highlights not only the health, but also the environmental benefits that could be achieved through both a black carbon cap and trade system or innovative clean energy technology.
Thank you so much. That's really fascinating research, and especially in California. My understanding is, our drought is not only caused by the reduction in precipitation, but also increased temperatures. Because even if we have precipitation, if we don't have the snowpack, that's going to lead to the depletion of the aqueducts and the reservoirs. Is that some of the findings that you've seen?
I think certainly it's a concert of many things with the drought in the Western United States, not only just black carbon, but also and temperature change. I think it's a concert of many factors.
Yeah. And then the other thing is, with black carbon, it also not only has global effects, but also individual effects. you know, when you think about, I lived in Ethiopia growing up, and the people would have fires inside the tukals, and it led to lots of health issues.
Respiratory problems.
Absolutely.
Well, thank you very much, and congratulations on your PhDs.
Thank you.
Our next presenter is here from UC San Diego. Please join me in welcoming Ellen Eshe.
The weather is getting weirder. Recent long-term droughts have been unprecedented in their severity, and this year's strong El Niño weather patterns brought predictions for heavy rainfall, despite their failure to materialize. For California, interannual rainfall variability is projected to further increase, meaning the concept of a normal year will largely be a thing of the past. I study how altered precipitation affects ecosystems with a particular focus on carbon cycling in coastal sage scrub. I manipulate rainfall quantity at my experimental site using these shelters to understand how the system responds in high and low rainfall conditions. Not surprisingly, rainfall amount affects plant growth and associated carbon sequestration. However, coastal sage scrub is being increasingly invaded by exotic grasses and forbs. These species have different sensitivities to rainfall as it relates to growth in comparison to natives. Thus, we also manipulate community composition to see if ecosystem response to rainfall depends on community identity. In high rainfall conditions, which is 150% of ambient rainfall in my experimental design, exotics do exceptionally well. You can see here that they produce nearly double the herbaceous biomass than did native-dominated communities under those conditions. Yet, with low rainfall, the exotics cannot sustain growth while the natives are less sensitive to rainfall and are able to maintain consistent biomass production, therefore continuing to provide carbon sequestration benefits in drought years. Now, we must consider other carbon pools too, one of which is indicated here. Senesced plant material is decomposed by soil microbial communities, which give off carbon dioxide. My research shows that exotics decompose much more readily than litter from natives, regardless of rainfall scenario. Thus, while high precipitation may promote biomass production by exotics, the increased decomposition rates associated with these species may diminish the overall effect on carbon storage. But how does this rudimentary equation for carbon storage is influenced by rainfall and invasion balance? Low and average rainfall years show more grams of carbon per area stored in native-dominated communities, while exotic communities store a nearly equivalent amount of carbon with high rainfall. I hope you'll agree with me that California's native shrublands can provide the important ecosystem service of carbon storage more reliably than invaded areas. Now, let's leverage that property to create a more sustainable future. Restoration efforts in our shrubland ecosystems, incorporation of natives into landscaping and urban design, and further research on carbon cycling in the face of climate change will help us better manage our land resources, both in the state of California and globally, for maximum ecosystem health and carbon storage benefit, among other services. Thank you.
Thanks, Ellen. That's terrific, and I know that a lot of our campuses are underway with this type of work. So
yeah, my lovely Photoshop there. Yeah.
Actually, you can find it on some of the actual campuses.
Yeah, well, the cool thing about this Photoshop, too, is so I took, well, this regular picture is from Google Earth, but I took this picture at the Scripps Coastal Reserve, which is one of the natural reserve sites that the University of California owns. And it's this great area, and it's used for research and outreach and education and community involvement and all of these great benefits. In this UCSD Hillcrest Medical Center, it occurs in historically shrub-dominated coastal sage scrub ecosystems. And we have the seed source. We have all of these resources that could potentially be used there.
Yeah. We actually have a quarter-long course that for undergraduates that travels to, I think, a dozen of the natural reserve stations. So,
yeah,
terrific. Thanks so much.
Yeah, thanks.
Our next speaker is here from UC Riverside. Please join me in welcoming Chao Wang.
What is carbon footprint? Here's the definition. A man living in a cave has few carbon footprints because he only needs to breathe and make wood fires. But for a man living in a modern life, carbon footprints can be generated from everything being consumed during any of his daily activities. To bring awareness of carbon footprint to personal level and estimate greenhouse gases emission more accurately for climate change studies, we may need to crowdsource people's daily activities and dig in to find useful information. So my work is to develop a platform that's doing this job. I call it Carbon Footprint Tracking Network, or briefly CFTN. It consists of two parts. One is a terminal application, and another is a cloud computing server. So people can share their locations, food consumptions, commute distances, and other daily activities through the CFTN app on their smartphones. And based on this information, each individual's carbon footprint will be calculated by the distributed algorithm. And customized tips will be fed back to them to help them to suggest their behaviors to cut down their carbon footprint. And meanwhile, all the data will be transmitted to the server where the overall greenhouse gases will be estimated, and a carbon dioxide concentration map will, meanwhile, will be visualized for future studies. So here's the sample system. It is based on the campus of UC Riverside. We try to make it more functional than only a data collection platform. It will also provide very detailed on-campus information. All the UCR students, faculty, and staff will be networked together and motivate each other by sharing their achievements of carbon footprint reduction. And they will also earn credits which they can use as coupons on campus by doing environmental friendly actions. So compared with traditional carbon footprint estimation method, which is survey-based, the CFTN offers a solution that is more user-friendly, more efficient, and more accurate. It will help people to connect together and involves everyone in to help them to strive in the right direction to achieve carbon neutrality. Thank you.
Thank you, Chao. That's fascinating. So it's sort of like the Fitbit for carbon emissions, but you can compare, share it on a network, so you have the guilt and the motivation of your friends.
Yes, right.
I know at Berkeley they have competitions in dorm floors, and when they're able to meter the dorm floor, it really causes the students to start to conserve more energy, and just the level of competition really helps in that.
Yeah, actually, if it works well at UC Riverside, hopefully we can kind of let every people in the UC campuses to use it and to make everyone to contribute.
Thanks so much. Our next graduate student is actually from UC Berkeley. Please join me in welcoming Alexis Schusterman.
Global warming is a global problem, but with 70% of CO2 emissions coming from a small handful of cities, global warming's origins are necessarily local in nature. Unfortunately, the current approach to carbon monitoring involves a small number of expensive instruments that, while providing a highly accurate integrated signal over a given area, cannot hope to resolve the heterogeneous landscape of contributions to an urban total. But in order to regulate CO2 more effectively, lawmakers will require more specific information about which of their policies are working and which resources need to be reallocated. So along with my advisor, Ron Cohen, we have constructed a novel CO2 sensing approach that seeks to address this mismatch in scale between science and policy. Beacon, or the Berkeley Atmospheric CO2 Observation Network, is a web of 28 CO2 sensors stationed at 2-kilometer intervals across the Oakland metropolitan area. Each beacon sensor is therefore much more sensitive to its unique local environment, allowing us to drill down into the integrated urban total and further differentiate between CO2 coming from cars, trucks, ships, buildings, etc. In order to afford this high volume of sensors, we rely on low-cost, off-the-shelf technologies previously believed to provide only moderate quality measurements. Over the course of our 3-year pilot period, we have developed in situ corrections for the influence of meteorology, as well as temporal drift. After applying these corrections, we demonstrate performance on par with instruments 100 times more expensive. Now we are generating the highest resolution maps of CO2 concentrations ever made. And from there, we can feed these observations into inverse atmospheric models that follow the CO2 molecules backwards in time and space to their point of emission. Comparing these emission maps with our prior estimates reveals where our assumptions about CO2 sources might be wrong. So for example, when the east span of the Bay Bridge was closed to traffic, Beacon was able to correctly diagnose that there were reduced CO2 emissions coming from the bridge on that day relative to what we would expect. And not only that, but Beacon was also able to show us where people were probably driving instead. And this proof of concept could be easily extended to subtler, more policy-relevant phenomena, such as the increasing fraction of electric vehicles. More recently, we have supplemented our CO2 instruments with sensors for toxic gases as well as particulate matter, and already the ratios between these trace species and CO2 are helping us to differentiate between different CO2 sources, such as heavy-duty diesel trucks versus gasoline-powered passenger vehicles. In the future, we look forward to informing more efficient policy at home, while also providing a validated framework for low-cost CO2 monitoring abroad, where emissions are on the rise, but resources are often scarce. Global warming may be a global problem, but Beacon can help us characterize and combat it more effectively, one neighborhood at a time. Thank you.
That's great research, Alexis. So I would assume that the fixed source emissions probably don't change that much, or do they? So is it mostly measuring transportation changes and also changes in climate and wind?
Absolutely, yeah. So the point sources are tightly regulated, so they're usually reporting their emissions, and we should be able to have a good handle on those. Although under-reporting, either consciously or unconsciously, is something that we could potentially catch with this system. But yes, traffic in particular is something that's really poorly estimated by what we call bottom-up inventories that just take vehicle counts and multiply it by some emissions factor. And those traffic counts don't do great at predicting things like congestion or cold start days when your engine is revving up from being cold in the morning. So these are the kinds of things that we can really help constrain from a top-down perspective.
That's terrific. Thank you so much. Our next speaker is Alanya Dunbar from UC San Francisco.
Yes.
Welcome.
Climate change is about humanity, and it already impacts our health, including respiratory and heart diseases, allergies, and mental health problems. And especially the vulnerable people are at risk, which means that health inequities will further increase. What can we do about this? Because health is a human right, so we have the responsibility to provide the public with the right information about how climate change impacts this fundamental right. And politicians, the media, and even scientists are not always seen as trustful sources of information. But according to the literature, there is a group which is seen as a trustful source of information, sees the majority of the public, and can easily link climate change to health, which increases personal relevance. I'm talking about physicians. And at this moment, there almost only exist editorials in the literature about how they can address this issue with their patients. So that made me want to do a research. And my research question is, what is the potential role of physicians in addressing the issue of climate change and health during their conversations with patients? And do they see themselves in a position to address this issue? And via snowball sampling, I conducted interviews with different physicians from all over the United States with different specialties. And I asked them, do you think it's important to raise awareness? How can this be done? What barriers might exist? And do you have experience yourself? And I'm in the data analysis phase now, but I will present some preliminary results. Striking is that after my first question, do you think it's important to raise awareness? Almost all physicians paused. It made them think. But after this pause, 13 out of 14 said it is important, but they differed in how and when this can be done and what they can talk about. Several topics came forward, including advice about how you can behave both in an environmentally and healthy way, advice about prevention, and the opportunities for patient activism. And something which seems really important is timing, especially to avoid fear. Different strategies were mentioned, including the usage of materials and the opportunities outside the consult itself, and it depends all on specialty. So it already seems like there is potential, and one of the most important follow-up questions is how can physicians do this in a patient-centered way? Although one of the answers was really progressive. It's always been about your health and illness needs and not about situating you as a human being in the larger health of the planet. I think that's probably a barrier to change one's thinking to say it's permissible to bring that into the conversation. But before this how question, physicians need to have the knowledge and personal beliefs themselves. I'm not sure that we should assume that every physician believes in the science of global warming, even though they base their practice on science. And I've never really thought about it as something that I would specifically talk about with my patients. So I think that this research can be the start of a chain of researches, not only about how we can raise patients' awareness, but also about how we can raise physicians' awareness first. Thank you.
Thanks so much, Alanya. And obviously this has an impact not only on patient care, but also on public policy. The AB 32 dollars, a lot of them are being directed towards neighborhoods, particularly that have these kind of disparities. And this kind of data, if it were fed back from physicians to policymakers, it would have great impact.
Indeed, it's not only about individual behaviors, but also about the communities. And actually, physicians have a lot of roles. They can advocate, they can talk with their patients, so they can be active in a lot of different ways.
Well, thanks again, and good luck on the rest of the research.
Thank you.
Our last pitch of the day will come from Mallory Hicks of UC Irvine. Thank you, Mallory.
Every time you take a breath, you inhale millions of tiny bits of material called aerosols. They're basically just solids and liquids that are floating around in the air, like smoke, smog, and even clouds. And there are so many of these aerosols in the atmosphere that they can significantly impact global climate change. With most aerosols, as we heard today, they can warm, especially if they're black. But it really depends on their color, white, black, or brown. So you've probably noticed that when you wear a black shirt in the sun, you get hotter than if you were wearing white. Well, I like to think of the atmosphere as the Earth's t-shirt. And if it's full of black aerosols like smoke, well, things are going to heat up. But if there's things like clouds, it'll cool the climate down. Now, brown aerosols fall somewhere between those two and can actually have a slight warming effect. But what makes them really interesting is that when they absorb sunlight, they can actually change color from brown to white. And that changes their effect on climate. I study how these aerosols actually change color when they're exposed to light. So, I make these aerosols in the lab using a machine that I built. It's called Mallory's Aerosol Generating Irradiation Chamber. But I call it magic. And it can make aerosols under controlled conditions in the lab by mimicking the processes that actually make the aerosols in the atmosphere. So once I make these aerosols, I can collect them, shine artificial sunlight on them, and measure how quickly they change color at different temperatures. What I've found is that at warmer conditions, this color change happens faster than at cooler conditions. And this is important because it means that brown aerosols in cold parts of the atmosphere will stay brown for longer and contribute a warming effect for a longer period of time. But why does this even happen? Well, we suspect that it's not necessarily a temperature effect. These aerosols are essentially the consistency of peanut butter. And can you imagine trying to swim through peanut butter? Probably wouldn't move very fast. But what if we were to heat it up? Then that peanut butter would start to melt and you could swim faster. The same thing happens with aerosols. As they get warmer, they get more liquidy, allowing the molecules inside of them to move around faster, and thus change the color faster. Aerosols are vital to our understanding of climate change. If we want to implement the most effective environmental policies, we need to know more about these aerosols. My work gets us one step closer and fills in one more piece of this climate change puzzle. Thank you.
Thanks, Mallory. That's terrific. A few years ago, someone came to me with a proposal that if we painted all of the roofs in the UC system white, the impact it would have on climate. And it was amazing. I mean, just by that one simple thing. And it sounds like your research is taking that just a step further into the aerosols that are produced.
Right. So generally, aerosols are thought of as being white, but sometimes they can change color. And so that's something that people aren't really taking into consideration at this moment. So it's something that if we want to have really good climate models, that's sort of things that we need to take into account.
Well, thank you. It's fascinating research.
Thank you.
So please join me in thanking our 10 presenters one more time.